Probability and two-ways tables. All right, so today we're going to get into probability. Again, probability is the measure of how likely an event will occur, given that all the outcomes are equally likely. So like flipping a coin is like 50-50, that you'll get a heads or you'll get a tails. All right, so here's kind of the formula, if you wanted to think of it as a formula for calculating probability. So it's the number of favorable outcomes. So it's what you want, all right? If you want to get a heads, then that would be the number of favorable outcomes would be 1. You only want one of those outcomes. And the denominator is the number of possible outcomes. So for like flipping a coin, there's 2 outcomes. There's heads or tails, all right? So let's look at an example by rolling a 6-sided die. So let's look at this first off, is what is the number of possible outcomes? If we roll a die, how many outcomes are there? Well, there's 6. You could roll a 1, you could roll a 2, a 3, a 4, or 5, or a 6. So there's 6 possible outcomes. So for all of these examples, we're going to have the denominator is going to be 6. Okay? All right, so what's the probability of rolling a 3? Well, how many favorable outcomes are there? Well, there's only 1 3 on the die, so we would say there's 1 favorable outcome out of 6 possible outcomes. All right? And then we talked about these in our last lesson about union and intersections. Okay? Sometimes it helps to think of union as being the word or, and the intersection sometimes helps to think of it as the word and. So if we look at C, what is the probability of rolling a 2 or a 3? So how many favorable outcomes are there? Well, 2 and 3, those are your outcomes that you want. So there's 2 of those. And the total possible outcomes, again, is still 6. So there's 2/6 or a third a chance of getting what you want. All right, let's look at intersection. All right, so again, we can use this word and. What's the probability of rolling a 3 and a 4? So this is one roll. What's the probability of getting a 3 and a 4 at the same time? All right. So this would be 0. There's no way that you can roll a die and get a 3 and a 4. So kind of keep in mind the difference between the word or like the union. We can take both of them together, and the intersection, what they have in common. So do we have a side that's both 3 and 4? So there are no favorable outcomes for that. Okay, only way you could get that is if we had a special die that maybe had 1 here and maybe 2 here and then a 3 and a 4. Okay, so you had more than one number on a die, except usually we have dots, so I don't know how you would actually be able to get that to work. But anyways, so there are cases where you'd have 0 probability. All right, this one here, if we're going to do the complement, again, that's what that means, complement, maybe another way to think of that would be not. Okay, so when we start doing probability, using these words sometimes helps us understand it better. And again, we said that this was or. So what's the probability of rolling, or what's the probability of not rolling a 2 or a 3? Okay. So we don't want 2 and 3. So what are our other options? Well, that would be 1, 4, 5, and 6. So that's there's 4 of those out of 6. Okay. So yeah, again, let me just say that again. So the complement is like the word not. So we'd say, what's the probability of not rolling a 2 or a 3? So that would be 4 out of 6. All right, pause and see if you can do these ones by yourself. All right, so hopefully you did that. So here we have 1/6. There's one favorable outcome out of 6 possible outcomes. Odds, we have 3 odds, 1, 3, and 5. So 3 out of 6. And then what's the probability of not rolling a 2? Well, that would be everything else. 1, 3, 5, 6, 4, 5, and 6, as long as you can count. I can't count, I guess. Okay, so that would give us, what, 5 out of 6? And then again, this symbol, the union, we're taking it all together, or sometimes it really helps to think of it as or. So what's the probability of rolling a 1 or a 3 or a 5? So that would also be 5, or sorry, not 5, 3. 3 out of 6. All right, so again, just keep in mind that the numerator is favorable outcomes, the number of favorable outcomes, what we want, okay? And then the denominator is always the possible outcomes. All right, and let's get into two-way tables. So this will be a big chunk of your homework and your test is two-way tables, okay? So this is just another way to compare data, especially if you have different types of variables. So we can have one type is like gender, and then that's our left side of our column, and then the top here we have is my secondary Math 2 classes. So you're in one of these. You're a subset of my classes, okay? And we're going to do some probability on it. As you notice, there are some totals that will help us when we do our calculations. But what we'll use a lot is the grand total, because that's our sample space. That's what we're picking from, all right? That's our total possible outcomes, all right? If I choose one of my students, they're going to be in that sample space. All right. So we'll probably do kind of the same thing. We'll do the left side together. You can do the right side, and we'll see where we're at. Okay, so what's the probability of, if I randomly select one of my students from the 156 students I have for Sec 2, what's the probability that they are male, right? So we would just look at male, and we'd see the total number of males is 71. So we do 71 over 156. One thing I didn't mention this is if you have a fraction, I'm going to ask you not to simplify it. I feel like you lose data because you're losing how many are in the sample space. There's a big difference between how many people you sample. If you did like 2 and you got 1 out of 2, I mean, it's the same as if you did 50 out of 100, but you have more data, so I think it's more important to not simplify your fractions. But if you're asked to, make sure you do that. If you do the test remediation on MathSpace, it will ask you to reduce your fractions. All right, enough said. So what's the probability of me randomly picking a A1 student? So how many A1 students are there? There's 27. That's what we want to pick from. And the total number of students is 156. What's the probability that I would pick a male and is in B6? So again, sometimes with the two-way tables, I think it kind of helps to kind of just think of the intersection. So we have males and B6. What they have in common is 14. If I can count. Okay, so we have 14 favorable outcomes out of the 156 possible outcomes. All right. Probability of randomly selecting an A1 or a B5. So we want to say, what's the probability of picking someone in, A1 or B5? And that would be, we can just add those together. What does that give us? 55? 55 out of 156. Okay. And then what's the probability of randomly selecting someone in B5 or B6 or B7 or B8. So we would take all of these B classes and we're going to union them together. We're going to add them all up. So another way to do that is you could do 156 minus 27. So let me just get my calculator out. 156. And either way, you'll end up getting, oops, if I do it right, is 129. So 120, I have 129 students in my B classes out of 156 total. All right, your turn to do those ones. Pause and give that a try. Beep. Okay, hopefully you did that. Probability of picking a female, well, we have 85 out of 156. Probability of picking a student from B6. So what do we want? We want someone from B6. That's 57 people, or 37 people out of the total. What's the probability of picking someone in B8 and is a female? Okay, again, this is like the intersection, so we would look at B8 and the females. What they have in common is 17. So do 17 that we want out of the 156. And then what is the probability of, again, this is like OR, all of B7, and we'll also take all of the males. Okay, so this is different. We haven't really done one like this. This is a little different because we were using the same type of variable, but these are like different. So we want to take all of the B7. So we'll take all of B7, that's right here. And then we also want all of the males. Okay, but what do you, if you maybe don't notice it, but if we do that, we'll end up having too many. And why would we have too many? It's kind of like if we take all of my class and all of Mr. Smolky's class, well, some of these students will be in the same. Some people are males and they're also in B7. So if we added the totals, we would get the 15 here twice. So we need to subtract that, okay? And there's different ways we can do it. I mean, we could just add all of these together. That's one way you could do it. We could take the 71 plus 15, and that would do it. Or we could do this plus this minus this, and that will do it too. So that's probably what I would suggest, is we just subtract what they have in common so it doesn't get double counted. So we'll do 71 plus 30, that's 101, and then we'll subtract 15. And that should give us 86. So 86 out of 156. Okay. So again, we don't want to double count it. We'll take all of the males and we'll take all of the B7. We don't want to double count the males that are in B7. All right, and then the last one is what's the probability of not, again, that's what that means, is the complement. So what's the probability of not picking someone in A1? So that's the probability of picking a B student. And again, we did that over here for I. So that would be 129 out of 156. All right, so that's two-way tables. We'll do one more example together, and then that will be about it, okay? So we will have something like this on homework or a review or a test where not all of the information is given. And we need to fill in the missing spots. So it says the school district surveys 100 elementaries and high school students about eating habits. The following table is missing data. Use what you know to fill in the missing spots and answer the following questions. Okay? So it looks like, since we know these are totals, we need to fill in what we do know. So if the total is 40, how could we figure out what this is? Okay, or if we know that this is 50 and for breakfast was 38, how do we find that missing spot? So hopefully you can figure out what that is. We just need to subtract. So we could do like 50 minus 37. So 50 minus 37 would give us 12. And we can check and make sure that works. Is 12 plus 28 40? Yes. All right, well, it seems like we're stuck. There's nothing else that we could figure out unless you realize that they tell us that the total surveyed students is 100. Okay, so some of the information may be given in the instructions. Okay, so if we knew that this was 100 from here, then we can finish the rest of the table. So this has got to be 50, and then this has got to be 60, and 22, I think. Yes. Okay, so just make sure if there's numbers kind of like in the word problem, then that might be part of the table. All right, so let's answer some of these questions. Suppose you randomly select a student, answer the following. Write the answer as a fraction and a percent. Did I have you do that up here? No, I didn't, okay? So sometimes I'm going to ask you to do both as a fraction and a percent, and we'll talk about that. So what's the probability that a student ate breakfast? So we have students that ate breakfast and we have students that did not eat breakfast. So the total that we would have would be 60 would have breakfast out of 100. And to write that as a percentage is we would simplify or divide 60 divided by 100. That should give you 0.6. And then we move the decimal twice and we'd get 60%. Okay, so we did that a little bit when we were doing exponential functions, writing decimals from percentages. All right, what's the probability of choosing an elementary student? Okay, so here's our elementaries, and our grand total for that is 50. So we'd do 50 out of 100, or that would be 0.5, or 50%. It's really easy when it's out of 100. A lot of the stuff won't be out of 100, so. All right, see if you can do C and D by yourself. Pause for a sec. Okay, so what is the probability of picking a high school student and eats breakfast? So high school and breakfast is 22. So 22, there's 22 students that are in high school and have breakfast out of 100. So 22% of high school students have breakfast. Although, I don't know, that seems a little too low, but who knows. Okay, what's the probability of randomly selecting an elementary student or no breakfast? So we're going to take all of the elementary students and all of the no breakfasts, and that's what we're looking for, okay? So here we have all of the no breakfasts. We have all of the elementaries, but we need to subtract 12 because we don't want to double count those elementaries that don't have breakfast. So we add 50 plus 40 gives you 90, and then we'll subtract 12. So that will give you 78, if I did that right, or 78%. Okay, well that is basically it. Here is another example. This is like what we would do as a class. We would have you guys come up with some categories that we'd want to use, and then people would just vote on what they would prefer. So if you want to answer the questions based off that table, you're welcome to do that. I will show you the answers, but I'll leave that to you if you want to do it. All right, so if you're going to do it, because I'm going to show it what the answers are. All right, so this is what you come up with. If you want to double check and make sure you're getting it, if you have any questions, let me know. All right, we'll see you guys later.